Hello and welcome to Fun with Dry Ice. We're going to be doing some dry ice experiments and some dry ice activities today. A couple of things to go over first. One of the first and most important thing is safety. We are working with dry ice. I'm going to bring this over just to show you real quick. Dry ice, very cold, 80 degrees below centigrade, 110 about degrees below Fahrenheit. That's below zero. It doesn't get that cold here. Do not want to touch this with your hands. I do recommend wearing safety goggles, so you're going to see me put mine on, and I'm going to wear them for the duration of this video. The dry ice, you're going to either have gloves on hand, or you're going to have some variation of tongs to touch with your dry ice. You're not going to use your bare hand. You also want to make sure when you purchase your dry ice, which you're going to get at your local supermarket, you're going to want to check with your customer service department, that you do not put it in an airtight container. You want it to be in something that can vent. You'll see that mine cannot be airtight, that whenever the pressure builds up, the lid's going to lift, and that's really important. You also want to make sure that if you keep your dry ice for a long period of time, that you put it in a room that has a lot of airflow. You don't want the dry ice to sublimate and build up. Now, since we've gone over safety, now we're going to go over the things that you're going to want to have for today. You're going to want to have a few things. If you have some ice, that's great. I'm going to do a quick experiment with some ice and some dry ice. If you don't, that's okay. You can just watch what I'm doing. You want to have some dish soap. Any variety, any color of dish soap will be fantastic. But have some dish soap ready to go. You want to have a handful of quarters. I have about 5. You don't have to use quarters necessarily. You can use any coin you want, but quarters are nice and big and they're easy to work with, so that's what I'll be using today. You also want to have some food dye. Some cups, some disposable cups are best, and I'm using clear ones. If you don't have clear and yours are slightly colored or they're the red cups, that's totally fine, but I'm going to be using clear disposable cups today. I'm also going to be using a bubble solution. You can find this anywhere. Any of the supplies I've mentioned so far, you can find at any grocery store or supermarket, and bubbles included. And then I'm going to be doing part of an experiment using this acrylic tank. If you're going to do this experiment, you can use a bucket, you can use a sink, you can use a variety of different things as long as safety is considered, but I'm going to be using this container right here. Now, let's get started with the first one. We're going to set this up and then we're going to put it off to the side. So I'm going to get my acrylic tank out. I'm going to get my container of dry ice. Oh, you know what? Before we do that, I almost forgot. I want to show you why dry ice is so unique. So I'm going to use my ice. This is water ice. Now I don't have to handle water ice with my hands or my tongs, but I'm going to anyway. I'm going to take a piece of it and I'm going to set it right here on the counter. Now I'm going to take a piece of the dry ice out. Frozen carbon dioxide, which has some very unique properties. Carbon dioxide is a clear gas. It's odorless, it's tasteless. This is what dry ice looks like. This is frozen carbon dioxide, and it's got a little personality right now. What I want you to see is the difference between the carbon dioxide and the water ice. One really important thing as I move this little piece of water ice around is you'll see there's a puddle. That's liquid water. As I move the piece of dry ice around, or it moves itself around, there's no puddle. That's because carbon dioxide skips a phase and it goes straight from a solid to a gas. Where water goes through the 3 phases, it's going to go from a solid to a liquid to a gas. Now, the reason this little piece of dry ice is moving around is part of the fun we're going to have with these experiments today. It's called sublimation, and carbon dioxide is being given off. Now, you might also catch some little wisps of what looks like smoke. It's not smoke, it's actually water vapor that's being condensed because the dry ice is so cold that when it sublimes, the carbon dioxide is condensing some water vapor, and you'll see that around the dry ice pieces. And as we're doing some different experiments, you'll see it a lot easier. Now, this is the reason you don't want to put this into a closed, non-airtight container when you're storing it for a long time. But for other shorter experiments, sometimes we'll put it into airtight things. So that's what's really unique about carbon dioxide, and we're going to look at some of those properties today. Now I'm going to get my tank out again. I'm going to move my little piece of water ice off to the side here. In my acrylic tank, I'm going to put some pieces of the dry ice around and let them sit for a little while. Now in your container, the better you spread your stuff out, the better layer of CO2 you're going to get. Otherwise, you might get more CO2 in one place than in another place, and it might affect the experiment that we're going to do at the end. So I'm going to put a few pieces in here. And it's okay if they break. Just dump them into your holding apparatus. And then we're just going to move this off to the side. And spread that guy back out. Perfect. Now if you're in a windy area or you have high ventilation in your house, you may want to cover this to help keep the CO2 from blowing out, the carbon dioxide from blowing out. All right. Now for our next experiment, I'm going to take a little Ziploc bag. And we're going to learn why we don't want to keep CO2 in an airtight container. You want to open your Ziploc bag, and you want to grab a little piece of your dry ice. Gummy bear size, marshmallow size, either will work. And you want to place it in there. And we're going to seal it up. And I want you to think about, we were just talking about sublimation, generating gases. Gases move a lot more than liquids and solids do, a lot more than solids do. And they tend to take up a lot more space. So we're going to see some things happen, which are going to be really interesting. But for now, we're just going to let this sit and sublime. So we'll just push that off to the side. And we'll move on to our next little experiment. Here, we're going to take one of our cups. I'm going to fill it with some water, warm water, about halfway, 3/4 of the way up. You can see I've done nothing special to it. It just has warm water in it. Now I'm going to take a piece of my dry ice out. And we're going to put a little piece of this in here. And I want you to think about what's going to happen. So we have really cold gas that's subliming, condensing the air as you can see, and I'm going to put it into warm water. And I want you to think, what could possibly happen to the water? Well, gosh, it looks like it's boiling now. And there's even what is water vapor coming out, so it has to be boiling, but it's not. What's happening in here is our dry ice is sublimating. So those bubbles of gas, those carbon dioxide bubbles, are coming up to the surface, and you'll notice that there's a fog-like substance here. That's water vapor. So we're creating a cloud. So what's happening is that carbon dioxide is so cold that it's condensating water vapor. It's getting trapped in the bubble. The bubble comes all the way to the top, and when the bubble pops, the CO2 and the water vapor are released. So we've created, it almost feels like nothing, the little cloud. We're also creating an interesting substance here. We started with water. We have carbon dioxide, or frozen carbon dioxide in there. We're creating carbonated water. Some of you will drink some version of carbonated water today. Do not drink this carbonated water, but you'll drink a version of carbonated water. I'm going to have to edit these because I did them out of sequence. All right. For our first experiment, I'm going to hide that over there. We're going to take a piece of dry ice out. We were talking about it with our water ice. So now I'm going to take a piece of dry ice out. You'll notice I have my gloves on, so I'm going to be handling the dry ice a little bit, and I'm going to set it on the counter. Now if you listen, you can hear it talking to you. What's happening is that sublimation that we're going to see a few times over in these different experiments is happening, and there's gases underneath this piece of dry ice causing it to move, and on occasion, depending on the substrate it's touching, causing a sound to form. So when I hold it in my hand, very lightly, and my hand's not getting cold, if your hand gets cold, please put the dry ice down and let your hand warm back up. As I'm holding it, you won't hear any sound because as it interacts with the glove, it's still subliming, but it's not making any noise. But when it touches the hard surface of the counter, there is a noise. And that's just the gases being trapped. Now this little piece of dry ice is very much going to behave like a hockey puck on an air hockey table. And it'll slide around because there's little gas pockets being generated from the dry ice itself, which allow it to move. Whereas on the air hockey table, you have little holes of air being blown onto the table from underneath, and that's what allows your hockey puck to move around. So this one generates its own little air pocket, and that's how it moves around all over the counter. Now, if we take this in my hand, and I'm going to take a quarter. Again, if you don't have a quarter, use whatever coin you have, but I'm going to set a quarter down. I'm going to pick up my piece of dry ice. I'm going to touch the quarter. And we'll see if the sound is the same as when it touched the countertop. Now, the same phenomenon is happening. It's just gases, CO2 gases being released, and it'll cause a sound to be heard. We call this the screaming quarter. Now, as you continue to touch your quarter, if your hand gets cold, again, please stop. Put your dry ice piece away and let your hand warm back up. And let your gloves warm back up. My hand is not cold. So as I touch the warmer side of the quarter, it'll continue to talk to me, making a very different sound than it did when it was on the counter. The substrates are obviously very different. This is a metallic quarter. The counter is not made of a metal. Now as the quarter gets warm, You can exchange, or cold, excuse me, as the quarter gets cold, you can exchange it for a warm quarter, and you can continue to do this. And listen to those gases being sublimated. Wow. Now, sublimation, right? Pretty cool, literally. Now we're going to take another cup of water. We're going to try another experiment. So again, you can fill it about halfway, 3/4 full of warm water. This time I'm going to add some food dye. And you can add whatever color you like. Whatever food dye makes you happy. I'm going to add blue. So 1 drop should be plenty. And I want you to think about the food dye and how it interacts with the water. And this should be expected. Food dye likes water. So it mixes very nicely with the water. And you can see I have a nice blue color. And it's starting to, isn't that cool how it mixes? Now, to get it to mix even better, we'll add a piece of dry ice. Now you should expect the water to bubble. We've seen what happens when you add dry ice to warm water. We're going to see bubbles. We're going to see trapped water vapor and CO2 come up to the top, and then we're going to see those release. What's different this time is we've colored the water. Is that colored water going to affect the water vapor, the carbon dioxide vapor, carbon dioxide gas, or anything else in here? Let's think about it. Let's see. Interesting. The water vapor is the exact same color as before. I will show you my previous cup. And I can put another piece of dry ice in it, just for contrast. But the water is very differently colored, so the dye is not going to condense out like the water vapor does in the cold temperatures. So the dye is going to stay in the warmer water. But we're going to see the same colored water vapor, and we're going to see the same kind of bubbling. What an interesting phenomenon. Now with these two, we could do something even more interesting. And look at my Ziploc bag. Boy, that has really changed. That has gotten very big. You can even feel the pressure inside. If the bag was still deflated, you would say the pressure inside is less or about the same as the pressure outside, but the pressure inside is much higher than the pressure outside now. Those molecules are moving gangbusters in there. We'll move that back off to the side and let it keep expanding. Now, we have our colored water and we have our non-colored water, both of them with a piece of dry ice inside. Now I'm going to add some soap, some dish soap, to both of them, and let's just see what happens. And you don't need much. Just give a little squirt. Your dish soap has food coloring in it as well, and it can change the color of your water. So if you see the water changing color just a little bit, that's what's happening. Now if you notice, the evolution of the water vapor has slowed down a little bit, or so it seems. It's just trapped in soap bubbles now. It's not moving on its own. It's being held in these soap bubbles. And if you touch them, the vapor will be released. But the bubbles aren't colored. The water vapor is still not colored. The carbon dioxide is still not colored. Interesting. And really fun. We're just trapping them with soap. Soap is really good at trapping gases, and that's why we like it for dish soaps. And there's some other chemical things that go on that help us clean things. But soap is really good at trapping gases, and we use it a lot for that reason in different experiments. But you'll notice the food dye hasn't gone anywhere but in the water itself. Hopefully not on you either. Now we're going to scoot these off to the side here. And we're going to do one more really cool experiment while we're watching our Ziploc bag. The Ziploc bag, of course, the bag is losing a lot of its flex and it's getting really tough to squeeze. So in my tank, we had the pieces of carbon dioxide, the frozen carbon dioxide that we spread around, and they've sublimed a little bit. You'll probably even notice that your pieces of dry ice have gotten smaller. That's what you would expect. This is subliming, so they're going into the gas phase. You're going to take your bubbles, and you're going to blow into whatever container you have your carbon dioxide in. Now you don't want to blow down into it because you're going to make all that carbon dioxide go all over the place. I just want to blow lightly across and just see what happens. Now with these bubbles, you'll notice that they're just sitting there. Evidently the gas that comes out of my body is not super heavy, even though I have some carbon dioxide coming out of me as well. Air is not as dense as carbon dioxide. Carbon dioxide is a dense gas, so it wants to sit on the bottom. So the carbon dioxide has formed like an invisible layer. which is causing these bubbles to look like they're floating. I say surfing. Whatever word you want to use to describe what's going on at that interface. But they look like they're just hanging out for no good reason. It's the carbon dioxide gas. That heavy gas is supporting those bubbles, and they'll sit there until they pop. Which is really weird. You can actually tell people it's like a Halloween levitation trick, even though it's just playing with scientific principles. And if you're lucky, on occasion, you can get one to freeze, which is really weird and kind of cool. No pun intended. But this one will last as long as there's carbon dioxide gas trapped down there at the bottom. That dense, heavy gas does some pretty interesting things. Well, I hope you've learned a lot of things about carbon dioxide today. It has a lot of really interesting properties. Sublimation is the focus of what we were doing many of these things today. If with safety in hand, you could have a lot of fun doing these experiments over and over again with your parents. Thanks for your time.